So today we are going to discuss the basic sorting techniques. So exclusively I am going to discuss the bubble sort technique today. So first of all, let's understand that what is the meaning of sorting. As said here, sorting takes an unordered collection and makes it an ordered one. Now you may see the example here. Now we have a list of items which are unordered, or rather ordered in a different way. Now if you want to order it, now the output would be looking like this. So here you can see it is unordered. So for example, if we want something to be ascending order, so the final output will be this. So to start with, so we will be taking today the basic and the simplest of all sorting techniques, that is the bubble sort technique. Now let's understand what is the technique that the bubble sort algorithm follows. Now as you can see, it is the simplest of all the sorting techniques which I have already mentioned, and the base logic is it is the comparison what we do it, in the sense that it is a pairwise comparison technique. So we will be understanding what is the meaning of pairwise comparison techniques in a very short while. Now the logic says this: if the left element in the pair is bigger than the right element, then swap. So this will hold good only if you want to order in the ascending order. So if you want to order in the descending order, then exactly it is the otherwise, in the sense if the left element is smaller than the right element, then swap. Now what do we do next? Once we swap, repeat the above process till all the pairs are exhausted. So this is the basic techniques. So with an example we are going to see what it is, right? Now it is called bubble sort because at the end of all pair comparison, the highest or the lowest element will bubble up, right? So now you can see here. So if you could see here, so our input element is 654321. Now that is what we have taken. This is swapped. Now you see here, now 6 and 5, so 6 initially was here and 5 was here. So the first pair is this, you can see it is marked in red. So 6 and 5, when it is compared, the left element is greater than the right element, so we will have to swap it. So that is the first pair. Then comes the next pair, that is 6 and 4. You may see that 6 is the left element in this pair and 4 is the right element in this pair. So 6 is greater than 4, so it is swapped. So now we can see the next pair becomes 6 and 3. So when we compare 6 and 3, so 3 is less than 6, or rather you can take the left element is bigger than the right element, so we'll have to swap it. So the next pair what we can see is 6 and 2. So 6 is greater than 2, we'll have to swap. Now we can see 2 comes here. So the last pair what we have is got 6 and 1. So 6 is greater than 1, so we'll swap. So the output looks like this. You may see that we have exhausted all the pairs here, and after exhausting all the pairs here, the highest element has bubbled and it has gone to its place, right? So this forms one run, right? Like that, to sort all the n elements, we will have to do n minus 1 times the same pairwise comparison. So notice that we'll see some few points here. Notice that only the largest value is correctly placed. All the other values are still out of order. So we need to repeat the process. That is what I said. Then what do we do? So how many times do we repeat this? If we have n elements, and if each time we bubble an element, we place it in its correct location, then we repeat the bubble up process n minus 1 times. Because if you have n elements, so we will form n minus 1 pairs. That's the logic. So this is the base logic of bubble sort algorithm. So why do we need bubble sort algorithm? We can apply this in n number of places. Thank you very much.